Okay, this is a situation where I have a bowling ball and a bowling pin, and they're separate before. Afterward, they're also separate. So I think, okay, what kind of problem is that? That's elastic, a part before, a part after. So I'm going to have to use the elastic equation. M1V1 plus M2V2 equals M1V1 afterward plus M2, oh, that 2 is too big, 2V2 afterward. All right, now we're going to plug stuff in. The bowling ball had a mass of 10 and originally had a velocity of 8.5. Plus, originally the pin was at rest, so even though it has a mass of 1, we put 0 here because 1 times 0 is 0. Afterward, we have the mass of the bowling ball, that's 10 still, and we don't know its velocity, so we're just going to leave it there. Plus, we know still the mass of the pin is the same, so we have 1. Oh my goodness, I just wrote that in meters per second. Jeez. Okay, so kilograms, sorry. So the mass is 1, and the velocity afterward is 11. Okay, so now we're going to try and solve for this velocity here. 10 times 8.5 is 85 equals 10 times the velocity we're looking for plus 11. So we're going to subtract 11. We're doing that because we're not just multiplying and dividing, we're adding and subtracting over here. So we don't divide. So 85 minus 11 is 74 equals 10 V1 afterward. Now we're going to have to divide by 10 on both sides. And we get 7.4 meters per second. And that is the velocity of the bowling ball afterward.